Okay, problem number 10. Here we go. This is kind of a disgusting little problem. Talking about a bunch of ants on a ship. Starts out there's 500 ants in the cargo hold of the ship, and in 1 weekend there's 800 ants. So here we go. These ants are taking off, man. They're going for a trip, and they are multiplying. So I hope this ship gets to its port soon. So they're going to ask us some questions. How long does it take the population of ants to double? Well, they gave us 2 data points here. At t equals 0, I got 500 ants. And at t equals 1 week, I got 800 ants. And they're going to ask us about things in terms of time in either in days or weeks. So you could either put a 7 here and do it in days, or a 1 here and do it in weeks. So I'm going to do weeks first and then change it into days. Okay, so here we go. 500, I'm going to put it into this form, AOBX. And 500 is my AO. If I put in 1 for the X, I can set this equal to 800. And that will allow me to solve for the B. So here we go, let's do that. 800 equals 500 B to the 1. Anything to the 1 is just itself. So divide both sides by 500. Cancel, cancel by the hundreds. 8/5 equals B, or 16/10 or 1.6 equals B. Dig it. Okay, so now that I have my equation, I can say 500 times 1.6 to the X equals ants over time. Okay, well, how long is it going to take to double? Well, if I put 500, 1.6 to the X equals 1,000. Now, here's a little shortcut. Because those cancel and this turns into a 2, the doubling time is just setting the equation equal to 2, because the AO value over here is going to be 2 AOs, and if I divide by AO, the AOs cancel and I just end up with a 2. So natural log of 1.6 times X equals natural log of 2, remembering that natural log of 2 equals doubling. That says doubling, by the way. So X equals natural log of 2 over the natural log of my base. And the doubling time then is going to be 1.47. And again, this was in weeks. So that, if I multiply that by 7, I get 10.32 days. So on the 10th day of the voyage, you've got 1,000 ants in there. Okay, part B. Here we go. How much time does it take to triple the population? Well, let's take our little shortcut here. This is an A, this is part B. So 3 AOs is just going to leave me with 3 equals 1.6x. And so natural log of 3 over natural log of 1.6 equals x. X equals 2.337 weeks, or 16.36 days. Alright, so how many ants now? 1,500 ants. These guys are out of control. Okay, part C. When will there be 10,000 ants on board? C. A. It's Canadian. 10,000 equals 500 1.6 to the x. See, these are easier than quadratics for sure. Okay, divide both sides by 500. 5 goes into 120 times. Take the natural log of 20 over the natural log of 1.6 equals x. And that is going to be 6.37 weeks. It's like a quarter of school. What kind of boat is traveling around for 6 weeks? Alright, so multiply by 7. It's, I don't know, somewhere in the 45-day range. Okay, now part D. That's a D, of course. Okay, you little ants. Let's see what's going on here. So, there's also an exponentially growing population of anteaters on board. All right. So, the anteaters are going to eat the ants, which is good. So that means as the anteaters grow, then they're going to take care of this ant population. But so far, they are not staying on the same deck. Some sort of separation issue going on here. All right, so here's what we're going to do. We got a ratio that we want 200 ants to every 1 anteater, right? So if I can get an equation for the anteaters and divide that into the equation for my ants, I'm golden. All right, well, let's do that. It says that at the start there were 17 anteaters, and it's doubling every 2.8 weeks, right? So if I double that, that's 34. And so if I simplify this thing, then I can get my b value. So here we go. 17 into 34 goes in there twice, equals b to the 2.8 weeks. If I take this to the 1 over 2.8 root, then my b value is 1.28, which is interesting that that's 1 over 2.8. Anyway. Okay, so now I have initial value 1.28 to the x. Now I'm essentially just solving this equation for x, which is easy. So 200 equals 500 over 17 times 1.6 over 1.28. And since these are both raised to the same power, I can just turn it into a fraction there and get 1.6 over 1.28 out of the deal here. So multiply both sides by 17, divide by a 500, cancel, cancel, cancel. How many times does 5 go into 17? It goes in there 3, carry the 2, 3.4 times. So 3.4 times 2 is 6.8 equals 1.6 over 1.28 to the x. Cool. Well, take the natural log of both sides. Multiply by, or divide by that guy, and that's all going to equal x, which is 8.617 weeks. Okay, well, if there's 200 ants, 8 weeks, there was 10,000 ants in 10 weeks. Holy smokes, that means there's 10,000 divided by almost 200. That's a lot of anteaters running around this board. What kind of ship is this? Okay, that's problem 9. And very simply put, when will there be 100 anteaters on board? Got it. Okay, there's your practice part. When will there be 100 anteaters on board? Done. See you in problem number 10.